We come to the business of writing scripts in MATLAB. It's a file which contains a sequence of commands which we want MATLAB to execute. It can be written in any text editor, but it's got its own editor which has some very useful features. Let's give ourselves the simple problem of computing the factorial of n, where n is any positive integer. Just before you're going to write any program, make sure that MATLAB does not have a program of the same name that you choose. So we're going to make a program which computes factorial of n, but we can't call it factorial because MATLAB already has that. If you type which factorial, it'll tell you where that function is. So we'll choose a different name and write a function, we'll write a program which computes n factorial for a given n. To open the editor, just type edit at the command prompt, or you can get it directly from one of the tabs. So on your screen, you'll see here, new script. There's a facility called a live script, which is a slightly different variation on this. For the moment, let's keep it simple. So you'll tap this new script and the editor will appear. We're going to write a script, an M file, and that's got to be saved somewhere on your hard drive. So you need to create a folder which is going to contain your MATLAB files. It can have subfolders as well. So on your own computer or in the lab, I think this would be L, there'd be some path, call it M files or something like that. I called mine M files. You can call them whatever you like, but that's how I'll refer to the folder which contains all of these M files. So make that folder using Windows facilities. Then we need to tell MATLAB where that folder is. In other words, we need to add it to the MATLAB search path. So you need to do that here at this button, set the path. When you activate that button, you'll see something like this. This is what I have, and this is the MATLAB search path. And you can add a folder or add a folder with all of its subfolders, and that'll appear here. And then you can move that to where you like it. You can move it up or down. This is the preference that MATLAB has. So it'll read files here first and then these ones and so on in this order. So this gives it a preference for searching. So once you've made your folder in Windows, add that folder to the MATLAB search path. So you've made a folder on your drive using the File Explorer, and we've got the text editor open, it's blank. We've saved a file called fact1.m into that folder. And now we're going to write the script. At the beginning of any scripts, put comments there. These little percentage signs are comments, so MATLAB does not read anything beyond the comment. And we're going to get input from the user. We're going to ask the user to give an integer, and then we're going to compute the factorial of that positive integer. So type help input if you like, and we're going to use a little for loop, same as syntax in any of the computer languages. So if you're unsure of that, type help for. To compute the factorial of n, this will give a little message in the command window. Ask the user to supply an integer n, and then we'll set the product to be 1 for starters, and then we will just go through in a loop making a product. So we start p to be 1, and then for k equal to 1, we'll take p is equal to p times 1, and then we'll increase it, and in that way we'll produce the factorial. and we'll get the output in a very crude way by just showing P at the end of it. And then once we've finished with this, we save it. Save it again now. And that'll be saved to that folder on your drive, which MATLAB can find. So when we run that program, you run it either in the window itself, in the editor, there's a little arrow there, or you type the name of the program there. So we run our program, it asks for n, we supply 2, tells us the factorial of 2 is 2. And we try it for various things. N equal to 5, 5 factorial is 120, so it's working. However, if we give it 3.45 or something, it tells us that the factorial of that is 6. If we give it a negative integer, it still supplies us with an answer. And if we give it a vector, it'll give us some output. And we need to fix that. We need to make sure that it works only on positive integers, that it does the right thing. So we will modify the program as we go. For the moment, it's very crude, and we will find ways of getting better output. So just type edit fact1, or get it up in the editor, and go to the first line where it says P equal to 1. And if you just tap the number next to it, it'll make a break point. And breakpoints are useful because when the program runs and it hits a breakpoint, it stops there and it lets you edit from there on, and then you can single step through the program. So this is what it will look like if you've got your editor up and you just touch this number here. That sets a breakpoint. And then if you right-click this, it allows you to then clear all the breakpoints, or you could double-click it again and the breakpoint will disappear. So the program will run until it hits this breakpoint, then it'll return to the screen. And then you can single step through the program, watching. You take your cursor and put it over the variable, and you can watch it change as it goes. If you go to the preferences, then and have a look at the keyboard shortcuts, here they all are. There's a whole list of them. It's just far way down the list. And you can use the step here by the F10, the F10 key. So instead of touching a button with the mouse each time, you just keep tapping F10, and that'll step you through the program. So set a breakpoint in that simple program, run it, it'll return the command, control to the command window, and then keep tapping F10, and you can watch as it goes through the loop. That is what you should just experiment with that a little bit. Use the keyboard F10 to single step, and then when you've finished, you just clear all the breakpoints. If you just right click, then clear all the breakpoints. Now the output from our little program was quite crude, and there are better ways of doing it, and we're going to use this fprintf function. This is common to many computer languages. You'll have a format string here, and the \n means when you've finished with that, make a new line, and it'll print what's in this matrix, which I've called out. You can make your own name, of course. So if I make a matrix, which in this case is just a column with 2 numbers in it, and I tell it fprintf, this is formatted data to file, this will appear in the screen. The value of pi2, first placeholder, and that D there indicates a digit. The first entry in this matrix here, out. So the value of pi2, that many places, and it's that will appear. is this, that there is floating point number. So with no specifications, we can make this, we can adjust this. So this is the second thing that it's going to print. That's the second placeholder. It'll print that. So it must be in a column. So it'll go down this column. The value of pi to that many places is that, which will occur in that placeholder F there. That is how it will print that out. So this is a placeholder, that's a placeholder, that's a digit, that's a floating point number. The syntax was this, that you're giving it a little message here, and if you want to see more about this fprint, then type help fprintf, and these are the options that you can have here for these placeholders. It's an integer, floating point, and this can be S is a character. You need new line at the end. Don't forget that. When you finish with this little message, new line, and then \T for a tab. Let's make a matrix. I'm going to call it out. Of course, you can call it whatever you like, but this is the matrix from which we're going to print. So this then is a matrix with a number of columns, and MATLAB will work its way down the columns. So when we have the fprint command, and from this out matrix, this particular out matrix, there are two placeholders, a digit and a floating point number. So it'll come to the first column, and when it's executing this command here, it'll say the value of pi to d places, that's the 0, is this one, new line now. So it's worked down this column, printing down there. Then it'll go to the next column, and the value of pi to 1 place is this, to 3.1, new line. And so it'll work its way down the columns of this printout matrix. That is what will occur in the screen when you invoke this command. Do this in the screen yourself. You should now pause this and go and do it in the screen if you can. You'll be using this many times, but look at the documentation for this fprint function yourselves. Now in the previous instances, we just put placeholder, this little percentage sign F, but there's an extension of that. You can specify the total width that is available for printing and the number of decimal places. So for example, if this is the out matrix, it's going to print as it goes down the columns. So we give it that same command, but now I'm going to adjust. Instead of just putting placeholder F, I'm going to tell it reserve 20 places for this, 20 slots, and 10 decimal places. So that's the syntax for it. That's the total width of the number it's going to print, and that's the number of places. So that says here reserve 20 places and 10 decimal places. When you do that, it'll come down here. So it'll say, so this is the first one it encounters, the value of pi to 0 places, that's this, is that's this one over here. And we've told it 10 decimal places. So there's your 10 decimal places. New line, then it'll come down to this one. The value of pi to 1 place, that's where it hits here, is this one here, 3.1, and it'll show 10 decimal places. And don't forget, MATLAB has got pi accurate to many decimal places. So we tell it must print out 10 decimal places, then it'll print out further down the line. So this is an extension of that floating point, print a floating point number command. We're telling it now how many places it's going to be reserved for the whole number and how many decimal places. Now, if you haven't had such a lot of practice with this, you should practice this now in the command window. Let's make our printout matrix like so. And then there's the command we're going to give. Do this in the command window. And now experiment here. So we're telling it the value of pi to, now I'm allowing 5 slots for what is going to occur here with 0 decimal places, 20 slots, and 10 decimal places. New line. So it reads down this column, print, print. Down the next one, print, print, new line, print, print, new line, and so on. So experiment here and here yourselves. So do this yourself in the command window. Give yourself this out matrix formed from pi as we did before. And then here I'm experimenting. So now I've reserved 4 slots for what occurs here. And you see how it leaves the 4 slots there. 20 slots here. So it gives you 20 slots for this floating point number. Here's another one. Change this a bit, and then this space here changes. So you can control the output to the screen. Now let's make some improvements on that program. I'm going to call it fact now. So take your fact1 program and change it, save it as fact now. And we're going to check that we do in fact get a positive integer from the user. And there's this function error which MATLAB has, and this is the syntax for it. If any of these things occur, this vertical line here is OR. So if the length of n is not n, in other words, if this n is a vector or a matrix, or if fixed n is not equal to n. Now, say n were 2.7, fixed n would be 2, then these would be not equal. So for an integer, fixed n must be just n, or if n is less than 0. So if any of these things occur, then the program will abort and produce this error message. And by the way, we went around in a little loop to produce the factorial. That was suboptimal. You just take the product of all the numbers from 1 to n, and that is n factorial. Then it'll print that out. We could even compress this program if you would like to make your programs as succinct as possible. You could just do it all in the command line here. Sorry, all in the fprint. You just do this here. I don't think this is a very good idea. Make a printout matrix and print from that. But if you like being very succinct, you could even do this. Now this new program fact is much better than that fact one where we went round in a little loop. We vectorized the command, if I can use that expression. So rather than using loops, we just gave it a vector, took the product of that vector, and that was our factorial. And you must now, I know it's a natural instinct for people who've done a lot of programming to immediately start writing a for loop. But bear in mind that MATLAB has got very powerful facilities using vectorized commands, and we'll see some examples of this just now. Here's another little example that we're going to try. We're going to get a certain amount of deposit. There's going to be an interest rate, and we're going to then earn interest for a number of years. And then we're going to report the value at the end. I've put this here. Any program you write, you put in comments the name of the program, say what it does, and put your name on it. For every program that you write, put your name on it. This is going to just display a line on in the window, and then it's going to prompt for a deposit, interest rate, and the number of years. Then in this program that we're writing, now I'm assuming that you've got the editor up. You type edit, get the editor, type in these commands, and save it again to that folder, which is in the MATLAB search path. So this is the program proper now. We've got a value here, which is the value of this whole annuity. Initially, it's the initial deposit that you put in, set the interest rate, and now we compute in a loop. So we're going to, for each year, we're going to increment the value by 1 plus R. In other words, this is the, if R were, say, here, say we had 10%, this R would be 1/10, this would be 1.1. So that adds the interest to the amount and increments the value for each year. So this is performing compound interest. And we will then print the final value out. So we get a printout matrix and we print from that. This is what will happen. Say we had 1,000 Rand, there's the interest rate, compounded for a number of years. Then this little program here will print out that. Now write this program yourself and run it and make sure that it produces this output. As an exercise, we're going to modify that program. So take your original, the one we call CI, Y, and we're going to print all the values. We're going to, instead of just printing out what the end value, we're going to show what happens when you put a deposit into an account, and we're going to show what happens for each year. So again, I'm soliciting input from the user here, and then we're going to compute and display all of the values as it goes. And this is how we'll do it. We're going to, if we're going to do this for n years, we need a vector with n plus 1 places in it. So I've made a vector with all zeros. It's a 1 by n plus 1 vector with all zeros in it. And then we're going to make the first value equal to d. You don't have to do this. If you left that out and just said v1 equals d, MATLAB would make a vector and it would put in the first position d. So it would make a 1 by 1 vector first, and then it would keep expanding that vector. But experienced programmers like to do this. They set up a vector with zeros in it and then replace the zeros. But that's up to you. So I've got my vector set up, waiting. It's got all zeros in it. I put in the first position, I put the deposit, I set the interest rate, and then we go in a loop. So we started at 1, so this value k is going to range from 2 to n plus 1. And then it'll compute the new value of k is 1 plus r times the previous value of k. And then we're going to make a list of all the years. So we started from 0 to n, that's n plus 1 places in that. And the value of v has got n plus 1 places. So we're making a printout matrix. This yn has got y in the first row and then the v in the second row. Then it'll print down the columns, as we've seen before. This minus 1 here makes it right justified. All of that information you can look when you look up all the documentation for fprintf. This is the out matrix that will be formed, and then it'll print from that. So when it prints, there'll be two things to print in each case. It goes down this first column. The value at year 0 is 1,000. That's when it's printing down here. Then it hits the new line, and then the value at year 1 is this value. Value at year 1 is this value, and so on. Just a note on recursively defined functions. Let's give ourselves this familiar Fibonacci sequence, where the value in position n is the sum of the two previous values. And it starts off at, say, 1, 1. So I'm making a vector whose first two values is 1, 1. Then MATLAB's got this very useful facility. We've got a vector f. If you say f and, that's of course the value at the end of f, and n minus 1 is the value just previous to that. So we're telling it the new f that we're making is formed from the end value, which was this, plus the one before that, which was this. So that's the f new, that's a new value. And now we're going to append that. So f here would be this list, and we now computed a new value, which we put at the end. So we're making a row vector. Starts off as a 1 by 2. We compute a new value. Now with this augmentation, we've got a 1 by 3. So that's what it would look like. And then you repeat that. So you keep on repeating this procedure and you generate a row vector. There's the first 2, and then 2 is formed by taking this plus this. 3 is formed by taking that plus that, and so on. The familiar, I hope, Fibonacci sequence. A slightly different way of doing it, we start off, we're making a vector f, which is going to be a row vector, and we set a counter, k equal to 3. Then we define how fk is formed. Fk is fk minus 1 plus fk minus 2. So it does the same as we did before when we used that end. Then we increase the counter, k. So it was 3, and now we replace k by k plus 1. So that's now 4. And then the value at this k being 4, is the sum of the two previous values. And then we repeat that. So you have a counter k, which you keep incrementing in a loop. It's the same output in a different way. Otherwise, we can make a for loop. So we start off with a vector, similar as we did before, and then we'll make a for loop. So from k running from 3 to some fixed value now, say 6. We tell it how to produce the kth value in this vector. It's the sum of the two previous values, and then this is what it will print out. Suppose I want to write a script which performs this now. So this is the sum of the reciprocals of the integers from 1 to n. Now we could do this. The natural instinct of some people is to do it in a for loop. So you start with your sum being 1, and you keep changing this s in a for loop. So for k starting off at 2, then the new value of s is the old value of s plus the next reciprocal down the line. And if you we'll format rational now, and then have a look at s. This is very crude. But there's a slightly better way of doing it, and that is to, rather than going through this procedure here, you make your s, set it at 1 to start with, and then you, for each s, you get a new s from the old s by adding the reciprocal of the next one down the line. There are better ways of doing this with MATLAB. This is a better way of doing it. You get the input from the user. So that's how far down the line you want to compute this Fibonacci sequence. You make a vector of the numbers from 1 to n, and you use these vectorized commands. You see what this is here? If you take the pointwise reciprocal of v, it takes v here, that's 1 pointwise divided by v. Of course, you can't take 1 over v. V is a vector. But you can take the pointwise reciprocal of v. So it takes the numbers from 1 to n, and then produces a new vector, which you're also calling v. But in the new vector v, you get the reciprocals of the numbers in the old vector. So if this were 1 to 6, say, then you'd have 1, 1 over 2, 1 over 3, up to 1 over 6. And then you sum those. You sum this new one. So this is a much better way of doing things. I said you must have a good shot at this exercise. This should cement home all of these ideas. Make sure that you have a really good try at this exercise, and I'll be in the laboratory to help. When you're working with a computer, you're working with a finite number system. All the real numbers that we know are approximated in the computer. And just to get some things clear, if we take the number 1.7261 and we round up to the nearest integer, 2. And if we use this 2 instead of the actual number x, there's a round off error, the difference between 2 and the actual number x. I've written a little function to do this. MATLAB has got its own as well, which rounds to p decimal places. The MATLAB is performing its calculations in a 64-bit word system. And there's always going to be a round-off error between the number that is presented to you to 16 decimal places and the actual number itself. So there's always some sort of inaccuracy. There's always a round-off error. And unlike with the real numbers, if you take a particular number, say 1, there's no next number up the line from 1. There's no next real number. But in the computer system, it's working with a finite number system, and there's a next number up from 1. And there'll be a round-off error. Here's a little picture for it. Here's 0 and 1. In the computer, there's the next number up here. Epsilon is the distance between this next number up from 1 and 1 itself. And then the round-off error will be twice that. Also, in the MATLAB and any computer system, there'll be a maximum real number, and beyond that, there's just infinity. So this is somewhat different from the real numbers. Just bear in mind, this is not the real number system that we're working with. It's a finite number system which approximates the reals, and that can cause some startling errors. So when you're working with the computer, bear in mind, if you pick a particular number, there's no next number up in the real number system, but there is in the computer system. And between any two numbers, there are infinitely many real numbers, but not so in the computer system. And in our real numbers, there's no maximum number, but in the computer system, there is a maximum number. And this becomes apparent when we start dividing by numbers x and take two numbers x and y, and they get smaller and smaller as n increases. So we're forming the quotient of smaller and smaller numbers. The calculation of this quotient will introduce round-off errors, and we'll demonstrate that with a little script. Here's a little script which is meant to demonstrate this. I've called it error demo, and we form the quotients of numbers which are getting, both of which are getting closer and closer to 0. So here I'm forming the quotient of 1 plus h minus 1 minus h over h. And of course, if your algebra is up to scratch, this is just 2. But here, the h that I'm forming is 10 to the minus n, and we're letting n get larger and larger. So 10 to the minus n gets smaller and smaller. And then we'll display what happens. And this is the output that we get. Bear in mind that 1 plus h minus 1 minus h over h is actually 2. in real numbers, no matter what that h is, but we are in a finite number system, so it's okay up to here. So now don't forget the 16 here. That's the n we were talking about, and we're talking 10 to the minus n, so 10 to the minus 16. And round about 10 to the minus 16, we get errors which compound, which produce the wrong result. This should be 2, as it is all the way here, and here it starts to go wrong. The round-off errors become significant. Well, here's a very instructive exercise which you should work through very carefully. This is just a rewrite of that script that we saw, which illustrates loss of significance, but try and get the printing to come as neatly as possible. I'll just click through these as each one appears. Try it on your own, write the program, and then proceed to the next one. So here's a very simple little conversion between Celsius and Fahrenheit. Here's a modification of it. Here's a problem to do with compound interest, which you should try and then modify that program. Here is these exercises that follow. You can do it with a for loop, or you can do all of these with a for loop, but MATLAB has a facility to avoid for loops in a lot of cases. So see if you can write a script which performs these operations in the most efficient way using all of the MATLAB vectorization facilities. So try this, and then this one, and then this one. Here is a similar sort of thing where you can avoid any kind of loops. Use vectorized commands. Here is the number e. There are many, many expressions like this for the number e. See if you can write a script which does this. And here's another one to do with compound interest with deposits. See if you can get the printing to come out nicely using fprint. And these solutions will be presented in the next video.